All right, so like I said, if you're able to print it, that will be helpful for you. It's not obviously a requirement, but it is helpful. Make things go a little bit faster. But I will try and be cautious of the reality that most of you were not able to print. Okay. All right, so 6.4 is all about applications. So with the applications, we are going to focus mostly on substitution and the elimination method. We will not do, you can do graphing with these, but we're going to focus on substitution and elimination. And so yeah, that's all I got for you. So the first question, we're going to go and it's instructed by step-by-step instructions. The rest of it is just blanks. So if you need to refer back to question number 1 to know what the steps were, then that's perfectly fine. All right, so number 1, 11 times one number is 9 more than 8 times another number. The first number minus 4 is half the second number. Find the numbers, okay? So with these types of problems, I always have students that are like, well, I don't even know where to start. So first thing to start is always to identify variables, okay? And you need to state what they represent. So you can pick any variables you want. I would highly suggest not including I or O, because I obviously is an imaginary number we've learned about before. And if you use O, it can look like a 0. So I would suggest not using those, okay? So typically we just resort with X and Y for a problem like this. If it's something with more detailed information, then we normally use a letter based on what we're picking. So in this case, since we're picking a number and another number, we can just as easily say X and Y. So we have one number, and then we have another number. Okay, you could also say number 1 and number 2, or the first number and the second number. Okay, those are both acceptable ways of doing this. If you guys want the lights off, can someone go turn off the lights? We don't. Solely okay if you need it off, like we did last time. All right, step 2. Step 2 is to set up the systems of equations. So for equation number 1, we're going to base it off the first sentence. So we first start with 11 times one number. So how would I start that equation? 11 times one number using my variables. What would I start with?
11x.
11x, good. Is, what does is mean in reference to word problems? Is equals, good. It means equal. 9 more than, what would 9 more than mean? Addition, so 9 plus. 8 times another number, 8y. Okay, equation number 2. The first number minus 4, how would I say that? The first number minus 4. X minus 4 is half the second number. How would I say that? Is half the second number. Okay, so I could say y divided by 2, or I could also say 1/2 of y, okay? And this year we've been working on using our coefficients for fractions, so I'd prefer you to write it like this. of 1/2 y versus y divided by 2. They mean the same thing, but in Algebra 2, we've talked a lot about using coefficient fractions versus using the dividing method. Well, maybe not a lot, but we talked about it. All right, step 3, solve your systems of equations using the method specified. So it will either specify substitution, elimination, or it might say you pick, okay? Now with this, with these types of problems, there's not necessarily a method that you can't use for any reason. It's just there's going to be methods that make more sense to use in reference to substitution versus elimination. So offhand, what would be one reason why substitution might be easier than elimination? Coefficient. Okay, so when you have variables that are alone, those are always helpful with the substitution method. Whereas elimination method typically has more coefficients to start off with. So, but for this one, we're definitely gonna use the substitution method. So which equation are we going to solve for and which variable will we solve for or should we solve for? Based on our 2 equations, which one makes more sense to solve for substitution method? Which one would be easier? That's already a single variable. The second one, yeah. And which variable? X. Okay, so if I substitute, or sorry, if I solve this equation for X, what would that equal? X equals 1/2 y plus 4. Good. All you have to do is add that 4 to the other side. Okay, if I did the top one, I would have to be doing some dividing and getting some crazy fractions in it, right? Not likely going to be a nice one to work with. Okay. Okay, now what do I do with this expression? Good, I substitute that expression for X in the first equation. So I'm going to have 11 times 1/2 y plus 4 equals 9 plus 8y. So 11 times 1/2 y is going to get me 11/2 y plus 11 times 4 is 44. Equals 9 plus 8y. Okay, from here, what should we do next? Subtract 11/2, good. Okay, someone other than Harper in person, please tell me what that would be. You can use a calculator. He said to subtract 11/2 y to the other side. Or in person, or sorry, or virtual can also tell me, maybe. What do we get when we subtract 11/2 y from 8y?
5/2 y.
We get 5/2 y. Everyone should have a calculator out. If you don't have a calculator, there's some school calculators you can borrow, but you should not be sitting staring until someone else provides that for you. If you don't have a calculator, please come grab one. Because you can't be using your cell phone, especially in person. If you're at home, you should not be using it either, but I can't really enforce that. Okay. From here, what do we do? You could have subtracted 8, but then you would have had a negative number. So you could still do that. It's just why deal with negative numbers if you don't have to. Yep. What do we do from here? Subtract 9, which gives us 35. Okay, 5/2 y. How do we solve when we have a fraction? What? Okay, we can multiply by the denominator. So that process would take me 2 steps. What would be a 1-step process? rather than multiplying by the denominator, then doing something else. What did I do as one step?
You can multiply 35 by 2/5.
Multiplied 2/5, which is the reciprocal. So I could multiply both sides by the reciprocal. So in the first option, which was given to me, which was multiply by the denominator, which is true, but then you'd have to divide by 5. So 2 steps still does the same thing, but typically we just multiply by the reciprocal. So once we do that, back to choosing our calculators,
Should get 14.
should get 14. And we're going to take that 14 and substitute it back in. Does not matter what you substitute it back into. So x minus 4 equals 1/2 of 14. X minus 4 equals 7. Add the 4 and x equals 11. Okay, so after you've done all your work in step 3, however substitution method you're supposed to be using, you will state your final answer using words, labels to make sure your answer is clear. So you will not just simply say x equals y equals or whatever variables you pick. You will just simply rewrite the initial definition. So we had a number and another number. So a number and another number, and fill in. Now in this case, are we going to have units on numbers? No. But my x value, which is a number, would be 11. And the another number, which was y, is 14. Right? In this case, we don't have any units to worry about, so therefore not needed in this problem. Any questions or concerns for number 1? Again, on number 1, the steps are written out for you. And the rest of the problems, there's just blanks. So it's just, and those blanks will more closely relate to what the blanks will look like on your homework or reviews or tests. This is what it more simple will look like on everything else. Identify variables, so it still tells you some of the information, it just doesn't tell you in the same like formatting. Okay, number 2, a music store offers piano lessons at a discount. The cost, what were those last words for the first problem at the end? Sorry, I apologize, didn't mean to go too fast on that. Make sure your answer is clear, possibly is what you're referring to. State your final answer using words and labels, aka units, to make sure your answer is clear. No problem. Thanks for letting me know. Again, if you're virtual and you can't print, feel free to just write an approximate, or not approximate, a summary of the problem or situation. You can always fill it back in later, depending on how fast you write. I just don't want you to spend more time writing the problem than actually solving it with us. Okay, if you're behind in problem solving, then you're not actually actively doing it with us. You're just copying it down, which doesn't really help. Okay. So number 2, a music store offers piano lessons at a discount. The cost for 6 lessons and a one-time fee is $300, or 12 lessons and a one-time fee is $480. What is the cost of each lesson and the one-time fee? And we're using the elimination method. Okay, so looking at identifying our variables, the best place to look for that is your question. So your question is asking, what is the cost of each lesson and what is the cost of a one-time fee? So therefore, my first variable is going to be based on that one lesson or each lesson. Okay, what variable you guys want to pick for that? Doesn't matter to me.
How about just the usual X and Y?
X and Y sounds great too. Okay, you don't have to be fancy. You can always just do X and Y the whole way through as well. All right, so X is going to be the cost of one piano lesson. Okay, because specifically it is the cost per lesson, so it is for the one lesson. Okay. And then the other is the one-time fee. Now, remember we've talked about before with variables, you want to be specific. So we wouldn't just say one-time fee, we would say cost of. Okay, you have to have a measurable sense on your variables. So cost of, length of, how tall, how many, it has to be measurable. Okay, if you just put one-time fee, what do you want to know about it? Okay, so cost of, that's something measurable. Okay, now let's move on to our equations. Okay, so the music store offers piano lessons at a discount. Great, that doesn't give me anything towards my equation. The cost for 6 lessons and a one-time fee is $300. Okay. The cost of 6 lessons and a one-time fee is $300. What would that equation be?
6x plus y equals 300.
6x plus y equals 300. Right. 6 lessons and a one-time fee is $300. Good job. Okay, let's see, someone new. 12 lessons and a one-time fee is $480. Levi, what would that one be? Can you try? 12 lessons and a one-time fee is $480. 12x, what'd you say? Plus y equals. Great job. Thank you for trying. Right. Oh, and then someone just typed it in the chat. Thank you. All right, good. So now we're going to go through the process and solve. And again, in this case, we're solving with the elimination method. So if it gives you a method to use, you need to use that method for your points to count. Okay. So I'm going to write down my information over here. And let's figure out what we're going to do to manipulate to solve. Now, looking at my equations, which variable makes more sense to eliminate? Why? Okay. Now, does it matter which one I use to manipulate? Not really. Neither one's going to make a significant impact. So what should we do for manipulating?
Just multiply one of the equations by -1.
Yes, someone said that. I just couldn't tell who it was. It was someone in this corner. So multiply one of them by -1. So let's go ahead and multiply top one by -1. So -6x minus y equals -300. Second equation doesn't need any manipulation. Therefore, I can add vertically, and those y's cancel. So I'm left with 6x equals 180. So therefore, x equals 30. Okay, I just got a message saying my internet is unstable, so I hope I stay on this all the time. Let me know if I freeze or anything. Okay, now we're going to substitute that 30 back in. Okay. So 6 times 30 plus y equals 300. Okay, 6 times 3, or 6 times 3, 6 times 30, let me clarify, is 180. Pretty easy because we just did that math. So therefore, y equals 120. Okay, so now again, when we go to fill in our answer, we're not just simply putting X and Y anymore. We're putting the actual definition of it. So just copy exactly what you had written before. So cost of one piano lesson was X, which is 30. And cost of one-time fee is, is 120. Okay, now based on how we did number one, this is all we had. Is there anything missing from this answer versus the last answer? The units, okay, and what kind of units would we be referring to in this case? Dollars, right? And I guess that's our assuming that we're referring to American dollars as that's the American sign for dollars. But yes, cost in reference to what we're working with would be American dollars, so the dollar sign. Okay, however, that doesn't mean I couldn't throw in a random type of unit of money, but 99% of the time, we're just going to assume it's American US dollars. Okay, how did number two go over? Questions or concerns? Okay, let's go ahead and move on to number three. This one's a little bit longer of a setup, but again, you can summarize if you cannot print. Okay, the drama club at NOMS, I don't know what that even stands for, sells hot chocolate and coffee at high school football games. Sorry, I'm trying to remember what that stood for. I remember Bergman and I talking about it, but I can't remember what it was. At the last game, they had sales of $200. They need to keep track of how many of each type of drink was sold so that they can make predictions for future sales. Monica knows that they used 275 cups that night. If the hot chocolate sells for 75 cents and the coffee sells for 50 cents, how much of each type of drink was sold? Oops. Drink. And we're going to be using the substitution method. Okay, so again, when we're looking for that variable, you want to go straight to that question. Whatever that question's asking, that's what your variables are, okay? So it's asking how much of each type of drink was sold, meaning one's going to be referencing hot chocolate and one's going to be referencing coffee. But what about those? We're wanting to know how much of each type or how many of each type. So if we want to just stick with X and Y, that's totally fine. Or you can throw in H for hot chocolate and C for coffee, however you want. There's no judgment if you just want to do X and Y the whole way, which is totally fine. So if we're going to say X, okay, since hot chocolate was the first one that was mentioned, we're going to stick with hot chocolate being the first one. So number of cups of hot chocolate sold. And again, it can't just be hot chocolate. It's the number of cups that we sold. Okay, how much of each type were sold? Because we already know how much each one is. We just don't know how many were sold. Okay, someone said they need more time to write the sentences. I do apologize. I'm trying to make sure we get through as many types of problems as possible. So please just summarize what you can for now so that we can try and get to the problem itself. So like you don't need the first sentence, right? You could just write $200 in sales. And then you can say 275 cups. And then you could say 75 cents hot chocolate, 50 cents coffee. Okay, all the rest of the words really aren't that important for the actual problem itself. Is it nice? Yes, but I do want to try and make sure we can get through as many problems as possible. So I apologize if you're not able to print. I just want to make sure we can try and get through as many problems as possible. Okay, so please know that it's not, you don't have to write every single word. I know if you want to, just try and see if you can come back and So then y is going to be the number of cups of coffee. Just interested based on my own knowledge, how many people do not like coffee? You're my people. I hate coffee. I only drink hot chocolate and I feel like such a child every time my friends are like, oh, I want this mocha, frappa, whatever. And I'm like, hot chocolate, I'll do that. Okay, so now we're gonna do our equations, okay? This one's gonna be a little bit harder to come up with equations, okay? Because again, we're trying to figure out numbers of each sold. So let's first try and build an equation based off the 275. So we know that they used in total 275 cups. So how could I build an equation based on that fact?
X plus Y equals 275.
I drink it every morning. You drink coffee every morning, you drink hot chocolate every morning.
Coffee.
Oh, coffee. But yes, X plus Y equals 275 would be correct. Okay, because we have a certain number of cups of coffee, a certain number of cups of hot chocolate, certain number of cups of coffee. In total, those cups have to equal 275 cups. Okay, now let's make an equation based on the money. Okay, so we first made an equation based on how many were sold in general. Now we want to make an equation based on the amount of money they made. So they made $200 that night. Okay, now in reference to my equations, I want you to silently come up with an equation over the next minute. I'll give you a minute. You really shouldn't need a minute, but a minute at max. So many emails this morning. Okay. In-person kiddos, go ahead and look towards someone around you and tell them what your equation you got was. Your virtual, feel free to tell yourself in the mirror what you got yourself. You are able to use decimals when we're referring to money. You do not have to use fractions unless fractions were provided to you. I just had someone type a fraction, that's why I said it. Sorry, I'm trying to click through the million emails I just got. All right, so someone new. What should we get for our second equation? Marcus, what did you get? Good. 0.75x plus 0.50y equals 200. And if you wanted to throw off the zeros on the front, that's also fine. If you had 0.75, that's also acceptable. Okay, if you didn't do the point, then that would be an issue because you would be saying $75 per hot chocolate and $50 per coffee. So you got to have the decimal. So equation number one was based on how many cups were sold. Equation number two is based on how much money they earned. So 275 was the number of cups in general. 200 is based on the money that they earned. Does that make more sense for equation one and two, the differences? Okay, good. All right, now we're going to be doing the substitution method, okay? Now, in reference to which one makes more sense, it doesn't really matter. So I'm going to go ahead and give you some time to try and solve this one, substitution method. I would suggest solving the first equation for either x or y and then do your substitution. So go ahead and do that. If you haven't already, or haven't already started. Okay, let's go ahead and discuss this one. So hopefully that was enough time for you to do that. I hope I gave you about 5 minutes. So doesn't matter which one you solved for. Let's go ahead and say that I solved for x. So then I would have x equals negative y plus 275. Okay, or you could say 275 minus y, doesn't matter. Okay, if you solve for y, you're still gonna get to the same answer, you just might get there in a different order. Okay, so therefore, that means when I substitute, I'm gonna have 0.75 times negative y plus 275 plus 0.50 y equals 200. And then when I distribute, actually, virtual kids, why don't you type in what you got as your answer, please, as I keep going to describe. So we distribute 0.75 times 275 is 206.25. Okay. Combine like terms, you should get negative 0.25y plus 206.25. Subtract that over, and get negative 6.25. Therefore, y equals 25. Substitute that back in. And what is right? X plus 25 equals 275. So subtract the 25, x equals 250. So therefore, the number of cups of hot chocolate sold, if I can spell chocolate right, sold was 250. And the number of cups of coffee sold, can't even spell coffee. I can't spell anything correctly. I'm not even gonna blame that on sleep. Is 25. Okay, how did that one go for everyone? I was able to get a few people to type in their response virtually. Okay, virtual kiddos, I'm going to be asking for more things for you to be typing in here. If you're not going to respond on the next couple of questions, I'm going to mark you absent because you may have just logged on and left the building because a couple of people are not responding at all. Any questions or concerns about number 3? Okay, let's go ahead and go on to number 4. We have 4, 5, and 6 left. All right. Amy wants to get some granola bars. At Kroger, you can get 6 strawberry and 4 cherry together for $6.90. At Sam's Club, you can get 5 strawberry and 9 cherry for $9.15. How much is each type of granola bar individually? So looking at my variables, let's ask for some virtual help from those that are not responding. So what are we looking for in my variables? What should be my variables? Joseph, can you tell me what our variables should be for this one? How much is each type of granola bar? So it's not going to be about the 6 strawberry and 4 cherry. That'll actually help us with the equation. So, but it is about the What are we looking for? Let's see. Thank you. How about Nicole? What are we looking for specifically in our variable? So strawberry and cherry is important, but not the 6 and 4 yet. What are we looking for specifically in our variable? In our definition, Nicole? Okay, Diana, can you help out? What should our variables be like? Christopher, can you help us out? Oh, there we go. X is number of strawberry. So a little bit more specific. Cost of. Okay, so the cost of is the important part. So it does say how much is each type. So the cost of is really the important part. So if you guys want to stick with X and Y, it's totally fine. So X was going to be the cost of, and I said the strawberry and cherry is important. So cost of the strawberry granola bar versus the cost of the cherry. My handwriting is just everywhere today. Okay, someone mentioned would it be Kroger versus Sam's Club? So in this problem, it's not actually asking the difference between the two in the sense of the different stores. The different stores is really just saying that you're getting the same price at either store. So it's assuming that the price per bar is the same at each store. Considering Sam's Club and Kroger are both the general brand of both companies. Okay, thank you for those that helped with that one. Okay, what is going to be one of my equations? So let's talk about the Kroger equation. Juan, can you help us out with the Kroger equation? At Kroger, you can get 6 strawberry and 4 cherry for $6.90. What would that equation be? Okay. Oh, okay, Ashley, thank you for helping. 6x plus 4y equals 600 or $6.90 is correct. Good. Okay, Juan, can you help on the Sam's Club equation? Juan. How about Jesus? Can you help us out on the second equation? At Sam's Club, you can get 5 strawberry and 9 cherry for $9.15. What would that look like? Jesus, what would that look like? Okay, good. 5x plus 9y equals $9.15. All right, now we're going to be using the elimination method on this one. So is there one that makes more sense to eliminate than the other in this situation? Is there one that is easier? Anyone can answer that question. Not particularly, right? They're all positives. Okay, neither one of them is a factor of the other. So it doesn't really matter which one, but which one should we, oh, someone said eliminate x. Let's go ahead and eliminate x, okay? So what are we going to multiply the first equation by? What? -5, sounds great. Okay, so that means the second one we'd multiply by +6, okay? Or you could have multiplied by +5 and -6. Again, that's how the elimination method kind of gets a little crazy because there's so many ways you could do it. So rewriting that equation. I'll give a couple people extra opportunities to try. Nicole, can you try and give us one of these equations? Sorry, I accidentally zoomed. It's gonna take a second to, oh, the zoom's fine, I guess. Okay, let's see. Darian, what should we get for the first equation when we multiply that out? And Dariana, what do we get for the other one? Yes, correct. Good. And when we add vertically, or I don't know why I wrote S, sorry, X, probably because I put S on my initial paperwork. I put S and C. So if I do that, my bad. Okay. Add vertically, what would we be left with? Nathan? 20.4, good. So therefore, y would equal 0.6. Now, in reference to money, would we just put 0.6? Yeah, we'd add a 0, so we'd put 0.60. Okay, good. Substitute that back in and solve for x. Substitute that back in and solve for x. As always, thank you for those that are responding to me in the chat. If you've been responding in the chat, I didn't call your name out because I know you've been actively listening without me having to individualize ask you. Okay, so can you substitute that 60 into either equation? Yes. You can substitute into the first one or the second one, it does not matter. Either way, you'll solve for x. We'll go in a second. A lot of people are still writing in the classroom, so I'm gonna wait until a few more people heads pop up so I know that we're done. Obviously, virtual kiddos, please also type in your answer of what you get so I can actively see if you're understanding or paying attention to class. The way of me keeping attendance records. And even if you're wrong, I mean, it at least gets me knowing that you have questions. And I'll send a message like try again or look at that again. Okay, Charlie, what'd you get? Yeah, awesome. Yeah. So if we substitute that in, 6x plus 4 times 0.60. I didn't write down that part. Oopsie, that's not what I wanted. Subtract over. You should get x equals 0.75. So looking at my cost. Okay, you also could have said price of, cost of, those both mean the same thing. Either way. Now, when we put our answer, are we going to need a label on our answer? Yep, dollars. So, and you can put the 0, you don't have to put the 0 at the beginning, but if you don't put the 0 at the end of the 6, then that doesn't really work, okay? Because you wouldn't say that it's 0.6. We would say 0.60 in reference to 60 cents, okay? When it's cents, you can also put the cent mark. However, I would caution you when doing that because what you can't do is put 0.75 cent because that means 0.75 of 1 cent. So if you're doing cents, you wouldn't put the decimal. You would just say 75 cents. Okay. Now, as a math person, I see these in grocery stores all the time. I'm not the type of person that actually goes up and be like, oh, do I get this for 75 cents of a cent? I'm not that person. I may mention it, but like that sign's not correct, but I don't actually ask for that price. So again, if you're going to use decimals, then you're using the dollar sign. If you're not using the decimal, then you use the cent mark, okay? But you can't use decimal and cent because that means 0.75 of a cent. So less than a cent. All right, number 5. All right, Ross Labs needs to make 3,200 gallons of a 42% acid solution. They have 36% acid solution and 54% solution. How many gallons of each type are needed to make a 3,200 gallons of 42% acid solution? Okay, now this is a very popular type of substitution or elimination system question. And once you get the handle of it, it'll make a lot more sense. But I'm sure looking at it right now, you're like, I don't know anything about percents, acid solution. I don't know how to mix those things. What does that mean? Okay, it's really less complicated than it makes it seem initially. It's all about mixing the two together. So again, the most important thing is to look at your question. So the question is, how many gallons of each type are needed? So we need to know the amount of 36% and the amount of 54%. And again, you can pick X and Y, you can pick different variables, okay, but we need to know the amount or how much of the 36% acid solution. And we need to know the amount or how much of the 54%. they have 36% and they have 54%. So we need to know how much of each of these. The question you're probably thinking is, how do we get to 42? What does that mean? Okay, well, we'll deal with that in the second equation, actually. The first equation, we're just going to be based on how many gallons we need in general. So similar to question number 3. Okay, number 3, we had a question based on how many cups and how much it costs. Okay, so in this type of question, we're going to have something similar. The first equation is going to be based on how many gallons. The second one's going to be based on the 42% gallons. So just looking at the gallons alone, how would I state that equation? So we need 3,200 gallons total. What would I say? 3,200 gallons total. Anyone can respond to this one or make a guess. Yep, x plus y equals 3,200. In total, we need 3,200 gallons. Okay, now the next one's going to resemble the money question on number 3, but it's not going to be the exact same. Okay, so let's look back at number 3 real quick. So on number 3, we had the cost of the hot chocolate, we had the cost of the coffee, and the total, how much they made. Okay, so if we're thinking about trying to find 32 gallons of a 42% acid solution, we need to know the different solutions, right? Now, will I use percents in my numbers or my coefficients? I'm going to need to use decimals because it's a percentage of. So therefore, I'm going to have 0.36x plus 0.54y equals. Now, here's the tricky part. What does it equal? Right? What? It's not 0.42. It's not only 0.42. I'll say that. Any other guesses before I help out on this one? This is probably the hardest part about this type of problem.
3,200 times 0.42.
What did you say, Charlie? Bennett, yes, you were correct. It would be 3,200 times 0.42 because they want 3,200 gallons of 42% acidic solution. So in your second equation, you have the amount of your first solution, the amount of your second solution, and then you have the total gallons times the acidic solution that they want, which is the 42. Okay, like I said, that's typically the hardest part of this question because no one really thinks about that right off the bat. There's always normally one person that comes up with it, but it's not a very common thing that people think about. It's a very science-based question. All right, now this one is solved by the substitution method. Okay, which someone had written earlier, they were solving for y. We can go ahead and solve for y. That's fine with me. So if we did that, it would be y equals negative x plus 3,200. Okay, if you solved for x, that's totally fine. Keep going with that. So therefore, I would have 0.36x plus 0.54 times negative x plus 3,200 equals. Now, at this point, you can just multiply 3,200 times 0.42, which is 1344. And then we need to distribute this. So 0.36x minus 0.54x plus 1728. Combine like combine like terms, we get negative 0.18x equals. You're fine. Sorry, equals negative 384. Sorry, I solved for x, so I'm having to recalculate the numbers. And then when we divide, you're not going to get an exact answer, but we're going to go off the approximate answer. So approximately x equals how much? Approximately, what does x equal? If you rounded it to the nearest whole. Shouldn't be negative. Okay. Oh, and again, the chat is both of you guys confirmed. So 2133 or 2,133 would be approximate. Okay, now it's not very common that you do have an approximate answer. That's just how this one kind of worked out. When we're dealing with the percentages of solutions or percentages in general, sometimes the answers don't always work out nice and clean. So sometimes you will have approximate. So if we substitute back in, we have 2133 plus y equals 3,200. So y is approximately 1,067. Good. And then it's all about filling out your information. I'm not doing anything different than what I wrote at the beginning, just rewriting it. What's going to be my label on this answer? Gallons. Good. So the amount of 3,600 acidic solution approximately is 2,133 gallons. And the other one was approximately 1,067 gallons. Right. Any questions or concerns about number 5? So what were both equations trying to find again? They're trying to find the amount of gallons per type of solution. So the first one is the total. So you need 3,200 gallons. So the amount of the first solution plus the amount of the second solution has to equal 3,200. The second equation is based on the actual percentage of acidic solution. So you have 0.36x for 36% solution, you have 0.54y for 54% solution, and then you have 0.42 of 3,200. So in that second one, you have to have a percentage on each, but you'll take a percentage of the total that you want. Okay, good. I'm glad that helped. All right, last one, number 6. All right, you have been given $10,000 to invest. Safe investments like certificates of deposits, which are normally shortened to CDs, pay about 5.5% interest. The stock market is much riskier, but pays about 12%. If you would like to earn about 10% a year on these investments, how much should you invest in CDs and how much should you invest in stocks? You may decide the method, okay? So I'm gonna go ahead and help you get started with the variables and equations, and then I'm gonna let you solve by whatever method you want to solve by. All right, so the question is, how much should you invest in CDs and how much should you invest in stocks? That's a pretty easy way to define my variables. It's the amount invested in CDs and the amount invested in stocks. You can pick X and Y, you can pick C and S, however you want to do it. Okay, when we are grading this type of worksheet, I'm grading more that you have the correct defined variable versus what you have as a variable. Okay, now it should be consistent. I do have students where they'll say X and Y and then all of a sudden change their variables. Why they're doing that, don't know. But you do need to make sure you keep the same variables. Okay, so we have amount invested in CDs and amount invested in stocks. So similar to the last one, we're going to need to talk about how much we have and the percentage of what we have. So what would be my first equation if it was based on how much we had? Good, X plus Y equals 10,000. Okay, and you don't have to put commas in your equations. You can just put. Okay. What would the second one be then? If the second one's based on percentages of interest, would it be 0.55x? 0.055. So because it's less than 10, that means it would be 0.055x plus, what would the second part be? 0.12y equals what? $10 a year, so it wouldn't be 10. 10 might be involved somehow. All right, there we go in the chat. Awesome. So it would be a 10,000 times 0.10 because it wants, if you want to earn 10% a year of these investments.
Or you could just move over the decimal one spot and it'd just be 1,000.
Correct, but we do need to write how we found the numbers. So that's why we write it like this. In the next step, you can do that simply for your calculation, but in the equations itself, I need to see where your numbers come from. So you never want your math teacher to be like, where did this come from? So that's why we're gonna write it out like this on the equation, but then when you calculate it, you can easily do that. All right, you may decide substitution, elimination. You may try and solve from here. We have 12 minutes left of class. I'm going to go ahead and say I'm going to give you about 5 minutes to solve this of your own personal time. You shouldn't need 5 minutes, but I'm going to give you 5 minutes. So 9:33, 9:34. Approximately. We'll stop. This one will also be an approximate answer. Okay, virtual kiddos, when you get an answer, please put that in the chat. I'm gonna go walk around and see how my in-person kiddos are doing. I apologize, I wasn't specific enough on my approximate. Because this is money, approximate it to the nearest cent, not to the nearest dollar. I didn't say that. I was going back and looking at my work, so round it to the nearest cent, not whole dollar. Okay, because there's lots of ways you could have solved this one. I'm just gonna put what the answers would have been, similar to the last one. I can go through a method if you'd like, but you could have done it substitution, elimination, and with that, within each of those, there's multiple ways you could have done that. So the amount invested in CDs is approximately $3,076.92. And the amount invested in stock is approximately $6,923.08. How do we do on that one? In-person kids, I see some nodding, thumbs up, okay. Okay, for answers that I got in the chat, I did get some of those. Some people had rounded to the dollar before I had mentioned it, so I apologize. So to clarify, as far as your rounding goes, if it's money, round to the nearest cent because you have that ability. If it's a whole product, like if it's a person or a candy bar, you would round to the whole thing, okay? So in this case, amount of gallons, we're rounding on number 5, but number 6, because it was money, we rounded to the cent. All right, that is it for today. I'm gonna post the homework assignment. That is not due until Thursday. Thursday is going to be your work day for the review. For those that are behind in testing, that is a makeup test day. Wednesday is also an odd this week, so that's just more opportunity or time for you to catch up on late work. If you're behind in grading, that's a great 40-minute opportunity for you to get some grading done, okay? You can also grade on Thursday, okay? So plenty of opportunities to be grading material if you're behind on something, okay? To clarify again, Wednesday will be a work day opportunity for you to work on this homework or any other homework. Thursday is going to be the Unit 6 review. Next week, your test will be on the following Thursday for Unit 6, okay? If you are still on Unit 4 and 5, you need to be working as hard as you can to catch up, okay? Your goal is to not have to go to extended or summer school. So if you catch up, you don't have to do that, okay? So have a great day and I'll see you guys Wednesday.